Hi, hello everybody, and welcome to our second mini class. And now I'm gonna to review our first class, the new generation of the 3D technology and the application. Let's take a little review. And in this class, I have introduced you the 4 parts, include the 3D and 2D integration model, and the 3D and 2D integration technology, and the multi-source 3D data integration, and the 3D interaction applications. And that is our SuperMap 3D GIS technology system. And in the data model, I have introduced you the 3 types of the model, the voxel grid and the TIM and the 3D solid model. And it could apply in many industries. And this 3 model is upgraded by the 2D model, like the 3D point, line, polygon, and the TIM grid. And then that is the application of our 3D solid model, the 3D printing, and the spatial analysis. And we have to do this. Our first exercise, do the build the shadow volume analysis, and then introduce you the TIM model. It could application in the geological bodies, and the voxel grid, that is field, 3D field data, and it could represent the 3D field, and it can attach on the 3D solid models, and it could also simulate of the sunlight hours, and it can applications in the earthquake and the air pollution. And then it is 2D and 3D integration technology. It includes data storage integration and the 2D and 3D integration scene construction. And we have done the exercise 2. We have to do the 3D trees, the 2D points, and represent to the 3D trees. And then we have done the this multi-source 3D data integration, and I have introduced you the multi-source 3D integration, includes the oblique photography mosaic model, and the BAM mosaic the terrain, and the progress of the 3D management based on the distribute technology, and how to solve the united management of the multi-source. And then that is a 3D interaction applications. It's lots of the applications of the 3D GIS, includes the VR, AR, and game engine, and the WebGL of the SuperMap that could browse our 3D data in the web browser, and it has lots of functions like the Patrick effects, and it could apply in the VR and AR, and this is a game engine. Okay, and this could be a plugin with UE and Unity, and it could apply. It could application. It could do the application by the wall and or simulate such a wall, and to apply in the multiple planning and the traffic planning and the fire platform. Okay, and that's a complete application of the 3D data. That is 3 applications, and that is our first class that I have introduced you guys. And if you are interested in this, you could look at it in our YouTube, and I can give you the link of this course, and let me find it, our link. That is in there. That is our first class link, and you could let me get, where is the checkbox? Where is? Okay, I will give our assistant.我给你一个链接，你帮我发到 chat box。Okay, and yeah, 这是 how to Control C and our assist 哎，什么鬼 ？To let's look at our let me check. Okay, and our assistant will send our link in the chat box. That is our first class chat box. That's our first class link, and if you are interested in it, and you could click it to look at our first class. Okay, and now let's start our second class. Before our second class, and I'm going to introduce you that okay, and for our first class. Okay, so before our second class, and okay, before our second class, and I'm gonna to introduce you our class. So our SuperMap training cap. The mini class is the first series of the 3D technology and application. And in this series class, and we are gonna to introduce you the 3D technology. And in our class, we have the 8 mini classes, and if you're punching and to do this quiz for 8 times, and you will get the certificate at the end of our class. So if you have not punched, you could scan this QR code to punch in, and this is the data that our class will use, and that is a quiz. And you could scan this QR code to look at our questions, and you could take these questions and listen our second class. So that's our punching QR code and the data and our quiz. Okay, and now let's start our second class. Okay. Our second class is a basic knowledge of the 3D scene. Okay, and so our first class, I have introduced you the 3D, the new 3D technology, and in this class, I'm gonna to introduce you the basic knowledge, the basic concepts of the 3D scene, and I will introduce you from these 4 parts. And the first part is the basic concepts of the 3D scene. And for our SuperMap iDesktop, so before introduce you the 3D scene, and we'll introduce you the SuperMap iDesktop. We will use this software to do some applications of the 3D GIS. Let me introduce. Wait me a minute. Okay, I'm sorry that my computer have some problems. Okay, let's start our second class. So before I introduce the concept of the 3D, and I would to introduce you the software of the SuperMap iDesktop that we will use it to do the many of our 3D analysis. And so iDesktop provides a wealth of the GIS functions and which can satisfy the conventional GIS requirements like the data processing and the data analysis and the mapping, and it also supports the plugin extension and the secondary development. And you can expand and develop the new functions as you need it. So today, and let me introduce you the 3D capabilities of the SuperMap iDesktop. Okay, and then let me introduce you the SuperMap iDesktop interface. The interface of the SuperMap iDesktop, and then let's open the iDesktop. Okay, so if you have not opened the SuperMap iDesktop, please open it. Okay, and that is the interface of the desktop. And after starting the desktop, and it will open the start page by default. This is a start tab, and where we can quickly open the data source and the data site, and also open some simple data, the simple map, and the simple scene. And there also have some online maps. And in the upper of the interface, at the left corner, it has a quick access bar. Okay, let's look at it. What? Let me look at. Okay, is there? Okay, and in the upper left corner is a quick access bar where you can zoom in and zoom out of the map and or something. And the following is our the function area, which is the ribbon style of the function area. So we can do the series of the GIS operations on this function area. And so at the left, there is the workspace manager, and where we can manage our workspace and the data source and the data size or something. And we can also see this data organization structure of the SuperMap. Includes a workspace and the data source, map, layout, scene, and the model resource or something. So for the data structure, and I will introduce you the later. And on the below it is the layer manager, which can manage the maps and scenes in the map window. And on the right is that is a catalog. That is a catalog manager. So for the catalog manager, if you have the works that you did not complete, and it can be opened directly here the next day. So for the next day, you could directly open your project at there. And there also have the map. Okay. And there also have the output window and the manager. So there have some windows to do this. So there also have the task manager and the output window as a corner. And okay, so that is our interface of the SuperMap at desktop. Okay, and then let's come back to the our PowerPoint. Oh, okay. I'm modifying my share window. So and then let's come back to our PowerPoint. Let me introduce you the data structure. So the data we obtain is organized and stored through the data organization structure. So if you understand what is a data structure, and you can better organize, you can better process your data. And the data organization structure mainly includes the workspace, data source, map, scene, and layout. So we have seen it in the workspace manager. And we can see that the data organization is similar to the tree structure, which can be seen through the workspace manager on the application manager on the SuperMap at desktop. So what we are so we could see that the workspace, it's a root manager. It's a root in the tree structure. And so today we are merely to talk about the scene. And it includes the screen layer, general layer, and terrain layer. Okay, and such as for the screen layer, it includes some static pictures such as logos, and for the general layer, and we could import our 2D or 3D data, include the vector, point, cloud, and model. And for the terrain layers, it can be imported into the DEM and the terrain data. So okay, and then let me introduce you the SuperMap, the organization. So each workspace has the tree structure as shown in the figure below that I have introduced you guys. So the workspace corresponds to the root node. And the workspace is contains the unique data source collection. We could say it includes a unique data source collection and the unique map collection. We could look at it. It's a unique data source collection and the unique maps collection and the unique scenes collection and the resource collection. And that is the resource collection is a symbol library, so which corresponds the trails node of the workspace. So the root node is a workspace, and the trails node is a data source, maps, layout, scenes, and resource. Okay, and at the data site, so it's a start for the data source, it's a start the data site, and the maps and the layouts and the scenes and the resource, it's a start in the workspace. Let's look at it. The data site is a start in the data source. And the maps, layout, scenes, and resources are saved in the workspace. It means that if we wanted to save our maps, scenes, and layouts, we must to create the workspace and save our workspace. And for the data site, it's saved in the data source. Okay, that is our organization. And then I'm going to introduce you in details of the organization. So first is a workspace. The workspace is used to save the work environment, and it includes the open data source, like the locations and opening modes, and save the maps, layouts, resource. The resource is a marker, symbol libraries, or the line, or the polygon, or the field symbol libraries, and the 3D scenes. So the workspace, it is a work environment, and it saves the result of this of your operations in your work environment, including the data source, data site, or the maps and the 3D scenes. And the workspace can be divided in two tabs: the file workspace and the database workspace. For the file workspace are saved in the form of the files. The SuperMap iDesktop file formats are the SMW and SXW. And the SMW is the default workspace file for the iDesktop. And the SXW, it provides the XML format workspace file. When we open the .sxw format workspace file with a notepad, and we can easily obtain the text information in the workspace, such as the data source, map, results file, and your results information, so that you can use this information to set the other workspace, especially the style settings in your map and your scene. So a database workspace is to store the workspace in the database, and it supports many storage in like in Oracle and in the SQL Server database or something. And now I'm going to take you guys to look at our okay, and I'm going to introduce you the SMW and the SXW data format. We could see that expand name is .smw, and that is default file, and that we often used in this workspace. And we could see that is the .sxw. And if we right click it and open it with our notepad, and like in this, we could see there have so many informations in this file, .smw file. And we could find its coordinate system, or its styles, or its resource, or something. We could use this file to set the other workspace. Okay, so that is a workspace. And then let me introduce you the data source. The data source consists of the various types of the data set, and is a physical storage of the spatial data. So the data source consists of the various types of the data set, and is physical storage of the spatial data. And the data source are used to store the spatial data. The data source can be saved in the files or the database. It's the same as a workspace. And so the data source can be divided to the two categories: the file data source and the database data source. The file data source is UDB and the UDD data source, and it's saved in the files with the extend name of the .udb and .udd two files. Then we creating a new UDB data source, and it will generate these two files at the same time. So what is the difference of these two file formats? For the UDB file and they have the same concept of the extent of the for the suffix. So in addition to the spatial geographic information, the GIS spatial data also contains the attribute information. So in the file data source, the UDB files mainly store the spatial geometry information of the spatial data, and .udt files mainly stores the attribute information. Okay, that is the UDD and UDB files. So for the UDBX, the UDBX contains the both spatial geometry information and the attribute information. So we mostly use this data source now. And it is more open than the existing UDB file, the type of the data source, and the data operation is more accurate and stable. And then there also has a database data source. It's saved in the database, and currently iDesktop provides the Oracle Plus or the Oracle and the SQL. Okay, and that is the data source. And then let me introduce you the data site. The data site is stored in the data source. And the data site, that is the vector data that we mainly use, like the line, polygon, point, and the text or the image. And so let me introduce you the data site. The data site is a collection of the data of the same type. So what does it mean? The spatial data is an abstraction of the real world. So the point objects in the real world are abstracted as the point geometric objects, and the line objects are abstract as the line geometric objects. So the concept of the data site is the same things are stored in the same data site in the type of the data set. For example, the point data site can only store the point geometric objects, and the line data set can only store the line objects. So therefore, the spatial data in the data source is organized into various types of the data set. That is, the data source is actually the data set collection, which contains the multiple data sets, like the point data size, line data size, and region data size. Or for the 3D, is a 3D point, 3D line, 3D polygon data sites. So they have so many tabs data site in the data source. And so the data sites are stored in the data source. That is important points of in our class. Okay. Okay, and then let me introduce you the layers. Okay. There have some problem. Let's look at it. Okay. Oh, it works. Okay, and for the layer, the layer is displays the media of the data set, and the layer helps to display the objects in the data set with the appropriate styles in the map window, and the map consists of one or more layers. So the layer is a visual display of the data set. And then we load the data set into the map window for display, and the layer, it will be created, and the layer helps the map to display the data set with appropriate styles in this map window. So the same data set can be added to the same or the different map window multiple times with the layers. And so that is the same data set can be given the different display styles in the different layers, but one layer can only correspond to data sets. So what does it mean? And let me give you a demonstration. And so that's our SuperMap at desktop. And then let me open one workspace. That is a demonstration, and you just to look at our screen. So, and let's right click one polygon and add it to the new map. Okay, and that is to add our polygon data. And if I have a question, whether we could add this polygon for the second tabs, and let's try it again and add it to our current map. So in the layer manager, we could see that is we add the base map as a 2 tabs, and that is with different styles. Which one is blue, which one is pink. That is our layer. So the layer is always to management by the layer manager. And the layers, we could see a layer helps to display the data set with appropriate styles, and the same data set can be added to the same map windows multiple times. That is the layers. And then let's look at the map. The map that's I will introduce you for our next series class of the 2D data. And I will now introduce you for this map. But that is a very simple definitions. That is just to display our data size and the layer. And the layout is used to compose the one or multiple configure maps and to print the maps. And then that is a resource. results are the collection of symbol libraries used in the maps and the scenes, and the results libraries contain the marker line and the polygon symbol libraries. And for our first class, I have introduced you our 2D and the 3D results. Okay, and then that is an important topic in this class. That is 3D scene. Okay, so what is a 3D scene? Let's look at it. The 3D scene, that could load the 2D and the 3D point line and the polygon or the text, image, grid, and model, and or something. So the 3D scene realizes the 2D and the 3D integrated display and management. It could save the 2D and the 3D data. And the 3D scene is also started in the file or the database through the workspace. And 3D scene just to start in the workspace. And so if we saved our workspace, our 3D scene will be saved. And then what is a 3D scene? Maybe you have some question. So 3D data could express all kinds of features with the elevation values. So how to display and store the 3D data? The answer is that we should take the 3D scene to start and display the data. And the SuperMap iDesktop provides the 3D scenes to store the 3D GIS data. And the 3D scenes use visualized technology to simulate the various geographic features and their spatial relationships in the real world. And it consists of the two types of the 3D scenes. That is plane scene and the spherical scene. So let's look at these two types of the scene. The first is the spherical scene. The spherical scene refers to a 3D scene in which surfer is used to simulate the surface of the Earth. So the spherical scene simulates the surface of the Earth with a sphere, and it supports the geographic coordinate system and the projected coordinate system. And our spherical scene defaults to the WGS 1984 data. So that's it. That is the question in our quiz. The spherical scene could support which of the coordinate system? The geographic coordinate system and the projected coordinate system. Maybe there have the two questions of this point. The first is the coordinate system, and the second is maybe why does it could not add the data to the spherical scene? And the answer is maybe it's a coordinate system, it's a plane and no projected system. So this is a very important key point in the spherical scene. And then that is a plane scene. The plane scene is to simulate the spherical surface of the Earth to expand into a plane. And it simulates the entire Earth and display the scene in the form of the plane. So it supports the plane coordinate system and the projected coordinate system. Okay, that is a plane scene. So how to control the 3D scene? And we could see we can use the mouse or the buttons in the map window and the up, down, left, and right buttons on our keyboard to control the 3D scene. And we can adjust its viewing angle and the rotation angle and the direction angle. Use this 3-way to control it. That is how to control our 3D scene. And then let's do exercise to do some operation in our 3D scene. And this exercise is to create the particle spatial effects in the SuperMap at desktop. Okay, and then let's open our SuperMap at desktop. Okay, let's open our SuperMap at desktop. And I will give you 2 minutes to open the desktop. And if you have some question, and you could ask me and my. Okay. I will give you guys the 2 minutes to open the SuperMap at desktop. Okay, and now let's do the exercise of the particle effect. Okay, start the SuperMap at desktop. And let's open the data of the CBD data. Okay, let me find our data, and I have give you the data of the named the basic knowledge of the 3D scene. And there have the cbd.udb. That is a data site, and I have introduced to you. Open the cbd.udb. Click OK. Click yes to open the data site of the CBD. To open the CBD data site. Okay, and then let's open this 5 data sites. Open this 5 data sites. Right-click this data site and add it to the new Spherical Scene. And right-click it and zoom to the layer. Okay. We have opened the 3D scene. That is the view of the CBD in the Beijing. And then let's create a new data site to start the Patrick effect. Start the Patrick spatial effect. Right-click the CBD data site, data source, the CBD data source, and open the new data site. Open the new data site. That step is to create a new data site to start our particle effect. Okay, so maybe you guys don't know what is the particle effects. So the particle system is the technology that simulates some specific appearance in the 3D geographic, and it's difficult for this phenomena to show their scenes of realities with other traditional rendering techniques. And the phenomena that the particle system are often used to simulate, like the fire, the explosion, smoke, the rain, the effect of the rain and the water flow, or the sparks, and the fallen and the cloud, fog, and snow, and so on. This particle specific effect. So that is a particle effect, and so for the particle effect, we must to create the CAD dataset to start this particle effect. And then and then let's create the new dataset of the CAD tab of the CAD. So the target data source is a CBD and the tab is a CAD. And then let's modify its name. We could modify its name. It's a particle. Okay, and then let's add it to let's add it. create a new CAD dataset and click create. And then let's drag it to our current scene. Or right click it, add it to the current scene, or just drag it. Okay, we have create the new CAD dataset. And then let's modify it as editable. We could just to click this pencil button or right click it and click the editable. Okay, that is and we will editable our CAD dataset. When we click it's editable, and it will to pop up the drawing tab. So let's look at the drawing tab, and there have the group of the particle objects, and we could add the one particle. So first let's add one fireworks in the sky, and click the fireworks, and it will appear that our mouse will appear that will edit effect. And then let's click the sky and to add our firework. Okay, and that is a way to add a firework. And then right click it to finish the edit. And then we could modify its position, or right click it, click the properties, right click the firework and click the properties. It will appear as a particle object management. Okay, and we could modify some parameters in this window. Okay, that is a way to add the particle objects. And let me review the step of this step. So first, create a new window, or add the CAD data set in the new window, and create a CAD data set in the CAD data source. And then put the CAD data in an editable state, and active the object's drawing tab at this time. And in the tab of the drawing, and in the particle objects group, we could select the particle that we want to join. And in the particle objects, we could select the tab of the particle and click the mouse on the appropriate position of our scene, and to draw the particle objects. Okay, that is a step to add our CAD, to add our particle with the CAD data set. And then let's select our particle and right click to activate the particle objects management. Click the properties to activate the particle objects management. And then the operating area is mainly divided into the 3 parts. The name window and the operation area, the name toolbars, and the parameter area, and the menu that we could click. And for our particle, the buttons, we could add particle or clear the particle. And then we could modify its coordinates of the X, Y, and Z. The 3D coordinates values of the particle object's position as the X and Y latitude and the longitude coordinate system can not exceed plus or minus 180 degrees. Okay, this is our particle management, and you could add another particle like the flare, and it could simulate the flare. Right click it, and we could see that is a fire or the snow or the rain effect. Okay, and if we select this particle, like in the particle object manager, we could modify its the more parameters of the particle. Like let's select the firework, and then it will activate the particle force, reflecting surface, and the effects. Okay, like in this particle, we could modify it, change its height, width, and to zoom in it or to make it more bigger, and like it's modify its height, width, and the particle count. And then there have the billboard. It's similar to the texture. The texture map used to carry a single particle on the interface image. So you can choose the way the object's surface and the camera. And there are 3 methods. Includes a standard point billboard, the orient along common direction, and the orient along Y. Okay, you could select it that you want to modify its camera. Like for this standard point billboard, the particle can, so use this billboard, the particle can always to face the camera completely. Okay, so for the orient along common direction, the particles rotate around a common direction to face the camera as much as possible. And for the orient along the y-axis, that is means to rotate around their own y-axis to try to face the camera as much as possible. And then there have the force. We could modify the size and its a direction of the x, y, and z. Or we could change its reflecting surface. The reflecting surface, it's realize the reflection effect of the particles in a certain position. And we could click this enable deflector and to change its reflect rate or its normal, the XYZ, that's the coordinate system. And for the reflect rate, that is to realize the reflection effect of the particle in a certain position. And you can either directly drag the minimum maximum slider of the to set its time, or you can click the number to tap the number to modify its value. Okay, that is the Patrick information. Okay, that's all. That is our first exercise. Oh, it is 4:00 p.m. So the time is okay, and then let's look at its our. That's okay. Then let's look at our second part, the 3D data tab and its catching strategy. And for this part, you may have this following questions. What is a 3D catch? And why should we generate a catch, or what kind of catching strategy for the different 3D data tabs? And first, let me introduce you the main tabs of the 3D data. The last class also introduced them in detail. First of all, that is model data. It includes precision model data that we use 3D Max to create it, or the Revit and other modeling software to make the BAM data and or something. And the terrain data is or the DEM data raster, or which can express the undulation of the terrain. And there are also very common image data, vector data, and the KM data or something. So, and what is a catch? The catch is a graphic display technology, and it's commonly used in the mainstream and geographic information system. And this technology greatly shortens the waiting time of users, and it improves your work efficiency and makes the browsing speed of the graphic data smaller. And according to the different usage scenarios, and the cache can be divided into the 2D cache and the 3D cache. The 2D cache is also called the map cache, which is to catch a map, and it is to catch the surface. So the 3D cache is generated by the scene catching, and it can be understood as a body generated cache. This course will focus on the 3D caching. And in SuperMap, the data is divided into the different the image collections according to the different resolutions or scales, and saved in the corresponding folders. And then the spatial index file will be created. And according to the different data, according to the different data types, that it will generate the cache will be divided into the vector cache, model cache, and terrain cache, and the image cache. And the following, I'm gonna to talk this part of the cache to you. So first, let me introduce you the vector cache, the 3D refined model, and the BIM cache. So for this cache, you could select the model data site and right click to generate the cache. And then the second method you could to generate the batch generation of the model cache. Okay, and let's do some operations for you to introduce the 3D cache. Okay, and let's look at it. Let's look at for, there have the second method of our cache. Okay, and let's look at the second method is the batch generation of the model cache. So that is a 3D refined cache, and it includes the 3D precision model data and the BM data. And after that, after we select the model data site and right click to generate cache, and it will appear the box like in this window. And after setting some parameters, click OK, and it will catch. It will generate the cache, and the generate cache format is a picture on the left. It's including a series of the S3M file folders and an extension named with .scp files. And after this, we will do some exercise, and I will introduce you in detail. And in addition, most of the model data contains many models. So how do we generate the model cache in the batches? And let's take a look at the second method. How to generate the batch cache. So for this step, and I will give you a okay, and let me do a demonstration of the batch of the cache. So in the 3D data tab, there have the cache operation, and there have the multi-cache operation. And click this model, it will pop up the batch build model cache, and we could click this select all to select all of the model cache, and to set some parameters. For these parameters, I will introduce you later in the exercise 2. And so that is the way to generate the many model data, the cache. Okay, this is a batch build model cache. Let me repeat it. It's in the tab of the 3D data, and click the cache operating, and there have the button of the model. Click this model, and it will to pop up the batch build model cache, and select all model data, and you could generate the many model data. And for this parameters, and I will introduce you later in details in our exercise 2. And so that is the way to generate our batch build model cache. And so let's look at, let's go back to our PowerPoint, and we could see, so maybe you have the question, we have lots of model, and thus our configuration file is multiple. So the answer is it's just have the one configuration file of the of our BIM of our multi-model cache. So that is batch generation of a model cache. So let's do our exercise 2 to generate the cache of the 3D refined model. Okay, and then let's come back to our SuperMap iDesktop. Okay, and then let me close the 3D scene, and then to generate the model cache, let's select the building of the CVD data source. Select this building and right-click it, and to find there have the generate the cache. Let's look at this generate the cache. Click this generate the cache, and it will pop up the box of the generate the scene cache. And it is used to as a model data and set some parameters of the 3D tail catch and to generate the 3D tail catch. And on the left side of the box, there lists the data source in the current workspace or the data source of the selected. So we have selected the building data source data site, and we just have the one data site in this list. And on the right side, all data sites in this data source will be listed. And you can use the two bars at the top of the box to filter and the search and the data site, or the add or the remove your data site. And when we then let's to look at these parameters of the how to generate the scene catch. For the catch name, you could to modify your catch name, and I will change it to the building. And then you could select its path of the catch. And when we creating a new 3D model catch, and it is recommended that the different 3D tail catches will be created in the different directories. Because when we generate the 3D catch, the configuration file.scv file will in the index file. So the catch directory and the catch file will be generated in the specific directory. So if we generate the two model catch in the one directory at the same time, and then these two 3D catches will in the same longitude and latitude range, and it may use the same catch directory and the catch file. So therefore, in order to avoid the abnormal situations, and it is recommended that different 3D tail catch should be generated in the different directories. So let's select directories. We could to create a new folder and to set its name. Building, and click OK to save our 3D catch. Okay, and then for our file tab, so for our file tab, we could select just one as 3 MB. And then let's look at the compressed tab. There have so many tabs of the compressed. So for the data of the different purpose and using the different texture compression method can reduce the amount of the video memory and used by the texture image. So we could select the method of the compressed texture to select its texture image. And for this parameter supplies type, It is used to size the subdivision tabs of the cache slice to create the pyramid, and the application provides the two methods, the quartz tree and OC tree. And then for this tail-wise, is a range of that is the range of the tail. It's generally the default. It's okay. And if the data accuracy is high and this tail-wise can be proportionately reduced. And if your data is raws and your tail-wise can be increased appropriate. And for your filtering threshold, and it's used to size the parameters for the filtering sub-objects of the query layer, and only filter the data of the LOD layer. So the default is a 2, and the unit is a pixel. So if you enter the 2, it means that the sub-objects smaller than 2 pixels are filtered out. So it will ignore the less than 2 pixels. And then let's look at there has a merge root node. After we checking this merge root node, you can size the numbers of the root node merging. And if you enter the 2, and the root node of the model will be merged the 2. Okay, so that is some parameters of the generate the scene cache. And then let's click OK to generate our the 3D tail cache. Click this OK to generate the cache, and we could wait for a minute to generate this cache. Okay. That is a little slow. Okay, it's a little slow maybe. Let's wait a minute. Okay, and we could see it's a successfully completed to generate this OSGB cache of the buildings. And let's look at this cache. Open our folder. And in this in the folder of the building, okay, we could see it generates the many of the folder, and it includes the S3MB cache. And for the configuration file, it's a building.scp. Okay, that is we have generated the cache layer, and let's could right click the scene, click the new Spherical Scene, and add this cache. So for the 3D cache layer, so for the model, refined model cache, we could right click the general layers and add the OSGB cache layer. Create the general layer and click the as the OSGB cache layer, and select that the cache we have generated, the building.scp, and right click it and zoom to the layer. We could see that is the cache that we have generated, and that is more quicker than we directly loading the model data. And that is our exercise 2 to generate our 3D refined model data. Okay, and let's come back to our PowerPoint. That is let me check. Is this okay? That is our exercise 2 to generate the cache of the 3D refined model. And for the 3D data application process, so I have introduced you the exercise to generate the 3D cache layer, and then let's look at the application process of the 3D Max model data. So first, we import the Max data from the 3D Max software to the SuperMap with a plugin, to the SuperMap iDesktop with a plugin. And then let's do some a series of processing and optimization optimization and the general cache to add to handle this data, and then add it to the iDesktop by right-click it to add the general to add the cache with in the layer manager. And that is the process of the 3D data application. And the data we obtain is organized and stored through the data organization structure. So if you understand what is the data organization structure, you can better multiple and process the data. And that is the scene that I have introduced to you. So there have the screen layer and the general layer and the terrain layer. So which data add to which layers, and let me introduce you. So for the screen layers, and it may be to add some static image like your company logo, your university logo, or some image that is static. And for the general layer, we could add the image data, the vector data, point cloud data, or something or some data. And with this data cache to add a general layer. And for the terrain layer, we could import the DEM and the terrain, the TIN data to the terrain layers. So that is a 3D loading method. Okay, let's review the 3D loading method. So if we have the data site, we could right-click it and add it to the new Spherical Scene. And for our normal layer, we could right-click it and add our image cache or 3D tile cache. And for the terrain layers, we could right-click and add the terrain cache. And there also the way to generate the 3D tile layers, and that is vector data to generate a layer, to generate a cache. And for the vector data, it's the same as the model data. We just to right-click our vector data and generate the cache. And after we modified its parameters, it will generate a .scp configuration file in our folder. And how to do, and what is the process of to import the vector data? We could imported it into the SuperMap iDesktop, and to do some symbolic to make its 2D to make this 2D data as to present the 3D well, like to do the 2D the water polygon to symbolic this water, the flow of the water, and then to generate the cache of the waters, and then right-click the general layer to load the cache that we have generated. And that is the process of the to add the vector data. And then for the oblique photographic data, and for this oblique photographic, and I am going to introduce you for our Fab mini class. And if you have interested in, you could concentrate our Fab class. And for the oblique photographic data, and which is different from the above two methods of generate the cache. So first, we should generate the configuration file by the functions to generate the configuration file. And then we should convert it to the S3M or S3MB format with the tiled storage functions and can be compressed and segregated at the same time. So we have two tabs. The first is to generate the config file and then to compress it. And then it will to generate this .scp file and the cache folder of the S3M or S3MB. And then that is the terrain and image 3D caching strategy. So for the terrain and image, we could select the data site and right-click it to generate the cache. That is the same as the model data. And for its difference, if you want to analyze the slope and the specs, so you should to generate a normal line. You must to check a checkbox of the normal line. And for the terrain data, it will generate its .sct data format, and for the image, it will generate the SCI 3D data format, data folder, data format. Okay, and then let's do our third exercise, the terrain catch, the TIN catching strategy. And then let's open our SuperMap at desktop. Okay, open the SuperMap at desktop. And then let's add our and then let's add our file. Open our data source. Open our data source. So click the new data source. Open the file data source. Open the file data source and open the Qingdao.udb. And then let's close this scene and add the Qingdao terrain layer. Add it to the new Spherical Scene. And add it as the terrain and the image. Click OK. And then it will to let's right click it and zoom it to the layer. Okay, that is our terrain layer. And then let's close it and right click the terrain layer to generate the cache. And it will pop up the generate the scene cache. And there have some parameters same as generate the model cache. And for the storage tab, we could select the compact and the block storage and the origin. And this system provides 3 tabs of the cache. And for the compact, it means that a certain compression and the merchant is used to compress and encrypt data when the cache is established. And for the original, it means that the data is not compressed. And the original information of the image data, it will be retained. And for the block strategy, it means that the data is stored in the fixed length block. And for our exercise, we could select the origin or the compact. Let's select the compact. And for the tile size, that is the size of each cached block file, and it's generated after the cache processing. And then that is the important function of the bring normal. If you want to do some analysis of your terrain TIN data, you must to check this to bring normal and to do some slope and aspect analysis. Okay, and then let's click OK to generate the cache, the TIN cache. And then let's go on to our PowerPoint. Okay, and then let's go on to our 3D flying route. For the 3D flying route, if you want to, why should we do this 3D flying? So if you want to show your boss or your colleagues or your teachers the 3D scene that you have made, you can use a 3D flying to show it. So the 3D flying is a browsing effect, and the flat route is determined by the presetting the position and the observation angles of the series of the flat observation point. And then let's do our first exercise, 3D flying. Let's look at the step of the 3D flying. So as a new flying route in a 3D scene, and we should first we should click this new button, and then to edit some parameters in the flying manager, and to adjust its accurate, and to adjust its rotate, and then to look at our 3D flying and to start it or stop it. And if you're satisfied it, and you should save your 3D flying. And let's look at our first exercise. Okay, and our terrain cache has successfully generated, and let's look at it. So we have generate this Qingdao terrain, and we could click this folder, and it will generate this .sct file, and that is our terrain cache. So and then let's look at how to create our fly route, and let's add our CBD data set to our spherical scene, and right click it and zoom it to the layer. So for the 3D flying, we could click this fly manager, and click the new to add the new fly route. And then we could click this toolbar to add a stop by the camera or add a stop by the clicking. So first, let's to set a route. I want to fly with this route from there to there. And then let's add our first point. Okay, so we could add the stop by clicking or add a stop by camera. So I have add a stop by the camera for our first point. And then let's open our camera wheel, the angle to add the next stop by the camera. And then now let's click add our third stop by the camera. Okay, that is a very simple fly route. And we could click fly to overview our fly route, and we could modify its position, like the longitude, latitude, or modify its speed in there. If you think it's slow, you could modify its speed, or you could click your stop and click your settings and to modify its rotation. Okay, so that is a way to create the fly route. And then I'm gonna to open the fly routes. If you have some time, you could do it by yourself. That is the fly route in our data folder. And let's look at this fly route. Okay, if you have time, you could do this fly route. Do the fly route like this to browse the all corner of our 3D scene. You could explore the operation of the fly route by yourself. Okay, because of the time, and you could do it by yourself. Okay, and then let's go through of our PowerPoint. Okay, that is our third exercise. Of our first exercise, the 3D scene construction. This exercise that we add the image, terrain, and the CBD model data, and so many data in our 3D scene, and save our scene and the workspace. That is exercise of our homework. So if you have time, you could do this exercise and save the scene and the workspace. And next class, I will, if you have done this homework, and you could send to me as a next class.